I was kind of surprised when I put on my abstract. I put in 20 years of MegaPipe as opposed to 20 years of MegaCam. MegaCam has been on the telescope now for since 2002, and I was expecting a talk from somebody else about the 2 decades of data that has been acquired. And then when I didn't see it, I decided to add something, a slot to my section to my talk. Now I really feel that this should have actually been given by one of the MegaCam um, astronomers. So Jean-Charles or Simon or Andrea or Heather or Emmanuel Bertin should be giving this section. But since they aren't, I'm going to give it for them. So here's a picture of the first MegaCam image that has made it into the CDC archive. As you can see, it's just a test image and not great. But MegaCam has gone on to do some really fabulous things over the decades. So lightning tour of all the large programs that have, and some of the smaller ones that have occurred over the years, starting with CFHTLS, which had 3 components: the deep fields looking for doing supernova cosmology, the wide doing weak lensing, and the very wide that was studying KBOs, and that sort of morphed into CFAPs and stellar populations. Roughly the same time was PANDAS studying the M31, the Andromeda Galaxy, and here you can see all the stellar streams that were discovered using MegaCam. The next sort of round of large programs included NGVS, Next Generation Virgo Survey, studying the Virgo cluster. And this was sort of the debut of CFHT as a low surface brightness instrument, where you can see the lovely, well, I mean, we're just talking about, Jean-Charles was just talking about his calendars. That would not be possible with most other telescopes, and certainly not without Jean-Charles's Elixir LSB processing system. And again, MATLAS, which was looking at elliptical galaxies, which, as it turns out, most of them are not actually, a pure elliptical galaxy. They all have sort of diffuse things around them. And this also uses the Elixir LSB system. So that was sort of the first round of large programs and science that was done. And then when HyperStreamCam came online, those were all the ones where MegaCam was the biggest, baddest, coolest wide field imager in the world. And then when HSC came along on a slightly larger telescope, significantly larger telescope and a slightly larger field of view, MegaCam sort of started moving into sort of more niche activities. So first of these is AUSIS, which is a study of the outer solar system, looking at KBOs. And what was unique about this was the fact that it relied, the unique feature of CFHT that AUSIS relied on was the fact that CFHT has this excellent QSO survey. So there were attempts to do something similar with HyperStreamCam, but really they were not actually quite as successful as AUSIS with a smaller thing, but a smaller telescope, but a better Q system. And then we move into things where CFHT still has filters that no one else does. So this is Vestige, again, going back to Virgo and looking at H alpha. And you produce these lovely images with the red shows the H alpha, the hydrogen gas being ripped off the galaxy as it falls into Virgo. And then the giant schmozzle that is Luau, Cephas, and Huygens. Luau started off as was the first part of it. It was the U-band survey looking at galactic archaeology. It was joined by that sort of morphed into Cephas, which was a U and R survey, which has morphed into Huygens, which is a multi-telescope UGRIZ sort of all the northern sky survey of taken from Mauna Kea and Maui. And again, what's unique, the features that are unique to CFHT that make this sort of thing possible is the U-band, because there's still no wide field imager that has a good U-band other than CFHT, and the fact that there's QSO. And the reason QSO is important in this particular case is for the R-band imaging. The R band requires really good seeing. Now, obviously Mauna Kea has good seeing, but there are other telescopes on Mauna Kea. But the fact that there's QSO, you can ask for only the best seeing, means that the CEPA's R band gets much better seeing overall on average than any other survey, any other ground-based survey. Turning now to some slightly smaller projects, but still fairly large. This is the CLAUDS survey, where again, there's a unique U-band component that complements the hypersupreme cam data being taken in the other bands. And this slightly less inspiring plot shows just how incredibly deep CLAUDS got. So the luminary magnitudes are pushing 28th magnitude over a fairly substantial fraction area of the sky. Pristine has been talked about a lot earlier this morning, or afternoon for you guys, I guess. And again, it has this unique H&K filter, which allows a whole bunch of interesting science to be done with a 20-year-old instrument. Then this is my favorite picture that was produced by MegaCam, which is a picture of myself talking to rock star Brian May, who's also an astronomer, as it turns out. And well, actually, the real cool picture is this one here. So this is a smaller, this is a picture taken thanks to MegaCam, but not with MegaCam, obviously. It's a picture of the most distant object in the solar system to be visited by a spacecraft, and that would not have been possible without MegaCam. Although it wasn't discovered with MegaCam, MegaCam was used to produce the astrometry that guided the first post-Pluto course correction for the New Horizons spacecraft that allowed it to get to Pluto with still a decent reserve of fuel. Sorry, get to Arrokoth, this KBO with a decent reserve of fuel. And then, so all those things, all those other things were sort of one part of what this picture is. This picture here shows the coverage of the sky as observed with MegaCam over the last 20 years. In red is data that has been fully processed, fully stacked, and is available for download. In blue is the stuff that hasn't been, and it's the stuff that's still proprietary for the most part. And so all the public data from MegaCam is processed by MegaPipe as it becomes public. And now I'm going to spend the rest of the talk talking a little bit about MegaPipe itself and why it is so useful for why it's so useful. So I'm just going to walk through the different parts of MegaPipe. It starts with the raw images. First off, it starts from the raw images, and it has the deturning, the flat fielding, and so on, is done using a separate pipeline from Elixir called Pitcairn. Pitcairn, the main difference between it and Elixir is that it uses the night sky images to build the flat fields, and this means that it can go slightly deeper than Elixir. So this shows the magnitude limit difference between Pitcairn and Elixir, and Pitcairn goes 3% deeper, which is not a lot, but on the other hand, it comes for completely free. The astrometric calibration of MegaCam data is done using a distortion map of MegaCam, which has fewer parameters than the standard way of doing things, where you would do a polynomial expansion for the entire astrometric to correct the astrometric distortion. Instead, in consultation with people who built MegaCam, I built a much simpler astrometric model where the distortion is modeled with only 2 parameters for the whole mosaic, plus linear terms per chip, and that means that you end up with a much higher, you end up with the same level of correction with far fewer parameters. The astrometric calibration has been done with a variety of reference fields over the years. Now we have Gaia, which means that there's no need for inter-image calibration. It can just be done straight. Each image can be calibrated by itself to completely acceptable levels of calibration.
2 minutes, Stephen.
2 minutes, perfect. The photometric calibration is done in 2 stages. The first one maps the correction, the photometric 0.0 with the focal plane of MegaCam, and this map shows how it varied from run to run, and this map can then be used to correct every image from a run. This next step is to calibrate each image globally, and that's done using PenStars. PenStars has really taken the challenge out of doing MegaCam photometry, because basically you can just bootstrap off of PenStars, except for the U-band, where, as you can see here, the SDSS actually has really crappy U-band calibration in some parts, and so you're forced to use a combination of PenStars plus Galax to do the calibration. And again, now each image can be calibrated separately by itself without having to rely on other to do some sort of inter-image calibration. The stacking is done on a system of tiles that map the entire sky. The red lines here show the nicely organized tiles on top of the dog's breakfast, that is the observing pattern of the individual images. And the same half-degree tiles are used for other surveys, so they're used for unions to stack HyperSupremeCam and PenStars data, and I've also stacked the entire Subaru SupremeCam, the old camera, using the same tiling scheme. So I'm just going to go crazy and leave this, try and run a movie over Zoom, which may or may not work, but this shows the buildup of images over the history of MegaCam, and the summary is that MegaCam has done spectacular work over the last 20 years. MegaPipe has been there since the beginning, and then following on from Daniel DeVoe's comments, where he showed that sort of half of MegaCam papers are archival. The color to that is that you have a good archive, it doubles your impact. And I'll just leave this video running and take questions.
Thank you, Stephen. Are there questions for Stephen? Everyone's mesmerized by your plot, your video, but Jean-Charles has a question.
It's not a question, it's a comment, but Simon is here. So I guess on behalf of all the past and current instrument scientists for MegaCam, we couldn't have done this any better. So thank you, Stephen.
Thank you, Jean-Charles.
I actually have a question about the calibration. On June 13th, there's a Gaia DR3 data that comes out where there's a spectrophotometry in all the visible and near infrared that can generate any artificial filter or can recreate any filter that exists within that wavelength range. Have you thought of using that for the calibration instead of relying on PenStars, for instance?
Well, it's worth pointing out that that calibration will actually be based on PenStars, or at least partially. So I'd rather just go straight to the source and use PenStars.
Okay, thank you. Yes, Claire.
Would that be possible to have the same model for other instruments at CFHT? Well managed, the processing well managed at CADC?
So it does require, it doesn't come with zero cost. It's just a lot cheaper than the original instrument. But so, for example, I used to do the same thing for WeirCam, but basically I ran out of time. There weren't enough hours in the day for me to do both MegaCam and WeirCam. So if you want to do WeirCam, you need to have a WeirCam person, a WeirCam Stephen Gwyn. And if you want to do all the other ones, you have to have someone who's dedicated to processing all the public data, or really enforce getting the PIs to kick back their reduced data back into the archive and sort of enforce that rather than, because they'll always just sort of dither rather than return it.
We need to move on. So we're going to have Arturo, and I always get your names the wrong way around, Lopez Ariste.
Thank you.
Who will be talking about vision, which is this idea of observing at the same time, if I'm not mistaken, with Espadon and Spirou.